In this lesson, we're going to go ahead and write tests for models. Now, when we were writing tests previously for views, URL paths, and templates, we wrote tests that tested all of those things because that behavior is so tightly coupled. Models are a little bit different, and you tend to write tests for models separately from the views, URLs, and templates. So we'll see how we write tests for models and some of the behavior around models. What I've done in our test app is I've gone ahead and split test.py into a module. So there's now a tests directory with a double underscore init.py, as well as a test underscore views. And I've created a new file called test underscore models, which you are seeing right now. I'm using Django.test, the test case from Django.test, instead of the test plus test case, as we saw at the end of last video, because I don't need any of the behavior from test plus for testing models. I've then imported tag from the test app models, right? So what we're going to be doing is recreating the tag model using TDD to see how we would follow TDD with Django models. I've then started with a really basic test. I've simply gone ahead and said, well, I would like to make sure that tag has the various fields that I expect to be on this model. To be able to do that, I'm using something we haven't seen before, which is the underscore meta attribute, and it allows me to just ask questions about the tag or to run specific methods that give me information about my model. So in this case, I'm just calling getFields, and it will give me the various fields that I have on the model, and I'm simply asking for the name of each one of these fields. I do that with a list comprehension, and so I'm just getting a list of strings. For more information about how meta works, I've added this line here, and so you can go read more about it. It is not something that you see usually when writing Django code on your own up until the point where you really need to write tests. It becomes very useful for writing tests. Or libraries, mind you. You might find that useful for writing your own Django libraries too. But back to the test. Once we have the actual field names, we want to say, oh, well, what are the expected field names? And you can see that I've got the name and the slug, which is what we're sort of used to. And I'm also taking into account the ID. This is the auto field that Django is putting on each one of our models so that we have a unique identifier on each one of the model instances in the database. And then all I do is I simply assert that these two lists are exactly the same. So no real magic on this last line. Now, right now, you'll see that if I load the second buffer here, I have nothing in models. So if I switch over to this tab and I run the tests, you can see that the first problem we're going to have is that we can't import tag from models. So what I'm going to do is I'm just going to say git next, where I will have made these changes, and I'm going to reload this file. Now you can see that I've gone ahead and I have a character field and the auto slug field, and the auto slug field is just being populated by name. This is exactly what we saw last time, but I haven't done anything extra. Now, when I write this model, I always have to think about the database migration. So what I've also done, I'm actually just going to create a new tab. So I'm over here in this third tab, and then I'm going to go into migrations, and I'm going to open up the initial migration that was created automatically by Django, or not automatically, I should say. It's generated by Django, but I had to use the make migrations command to generate this file. You can see that it goes ahead and creates the tag model with the various fields that I have asked it for. And this way, if I were to share this work with another developer, they would have the migration that allows them to have a database with the same schema as I am currently using once I actually migrate the database using this migration file. So as a quick primer there, if you were, so our Docker Compose setup actually does this for us every time we start it, so we don't tend to worry about it too much. But if I were to do this, I would normally want to do something like this. I would start by saying manage.py make migrations, and this would generate the file that I just showed you. And then once we have that file and I'm happy with what it's going to actually do to the database, I can take that file and apply it on the database, and we'll go ahead and create a whole new tag table where it will store all of that data for us. So once we have that, now we can run the test, right? You will see some very unhappy errors if you don't have this migration file when you run the tests. But now that we have the changes to the model and we have our migration file generated, we can go ahead and rerun our tests. And so I start by doing that, and lo and behold, that works exactly as expected. Great. So our next test, if we come back to our test file, we load this in. So we've made a very basic assertion about the fields, but we don't have any of the extra behavior around what happens when we interact with the tag when, say, creating tags. One of the key things we want to do is we want to make sure that a tag's name is always unique. So what we can do is move into the future and then reload our test file, and you can see that I've written a very quick test, and the entire goal is to make sure that tags are created only if the name has not already been used. So to do that, I simply create a dictionary with name equals A, and I use that dictionary to go ahead and create a tag object. And what I want is I want, in the event that I call that same piece of code, I want Django to raise an integrity error. I want it to say, no, 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 you can't do that. So if I run the tests here, we're going to go ahead and just run the same test app. I see that integrity error is not raised, right? At the moment, Django is not stopping me from creating two tags with the same name. Now, because we're using AutoSlug field, the slugs on both of these will be different, and so we actually would be able to access them. But at that point, you know, we're thinking about this as a categorization system, so we don't want to have a tag with the same name, regardless of what's happening on the slug. Now, we see that this is failing, so we move into the future. And I'm going to load models, and it says, I noticed that your file has changed, so let's load it. And the big key difference here is all I've done is add unique equals true. Now, similarly, if I've changed a model, I have to go and create a set of migrations. So I run make migrations again, I make sure that that looks the way I want it to, and then I actually migrate the database if I'm happy with what I'm seeing. So here you can see, yep, I'm depending on the initial migration, and what I'm doing is I'm changing the tag model's name field, and I'm saying, oh, well, I would like to make this unique. Now, if I have not given this off to any other developers, I've not pushed this to production, it would be in my interest to try and take these two migrations that I've created and make it a single migration, because any migration file takes a certain amount of time for computation, takes time to then go ahead and change the database repeatedly, and if we can shorten that time, we are shortening the amount of time it takes to deploy, and that is in our interest. So, if this were a more serious production app, I would be replacing that initial one as long as I have not already handed that migration off to anyone else or any other system. But for the moment, I'm happy with what I'm seeing. I'm happy that that is committed, and I expect that this is going to help us pass the test, so I can come back and now run the test now that I have the changes to the model as well as the migration file. And lo and behold, it works as we expect. Fantastic. Now, not only can we make assertions about the actual internals of the model or what happens when we create it, we also can write assertions about what happens when we get data from the database using the model managers. So to that end, if I move into the future and I reload our tests, all the way at the bottom, you can see that I have written test which checks the order of the tags when they're pulled from the database. So to ensure that there are tags in the database, I've gone ahead and created 4. And you can see that I've created them in no real particular order, but I have some lowercase letters and some uppercase letters. I then pull this, and I just get a list of strings here. This is what the values list is doing and what flat equals true does. It allows me to just get a list. And when I compare the actual list pulled from the database and what I expect, you'll notice that I'm putting the capital D first. That's not usually what humans think of as alphabetical. However, a lot of databases will take uppercase letters first and then lowercase letters. There are things that we can do to change this ordering. We could go ahead and make it so that uppercase and lowercase appear at the same time, but that is not the point of what we're trying to do. I'm just trying to demonstrate a test that allows you to assert certain kinds of behavior on when you are querying data. So I'm just going to let the database do what it does by default. So once we have this test that asserts that this is going to be in a specific order, I come back to this tab and I run our tests, and lo and behold, we can see that the order that comes back is not the order I would like. Now this order is the order things were created in because it's the order of the IDs. So this is not immediately apparent as you just see this out of order, but this is ID1, ID2, ID3, ID4 in our database, and that's sort of what it is by default. And that's great for the database. It doesn't make a whole lot of sense for us, which is part of the reason ordering can really matter. So what we're going to then go ahead and do is we're going to move into the future. Now, I reload models, and you can see I've just created a nested meta class, and I've specified the ordering is according to name. Now over here in migrations, you can see that I have not created a new migration, but however, I can run the tests. There's a little bit of a gotcha here, which is that we always want to make migrations when we change most things about models, not everything. So if you're changing specific methods, the migration systems won't really care. However, the moment you're changing fields or meta or anything of the sort, you do want to be running migrations, and the tests will not always get this. So this is a bit of a gotcha. So my tests run fine, everything looks fine, but the migrations have not run as you might expect. And so I demonstrate this. If we move into the future, you can see over in my third tab that there is in fact a change here, and that Django would have wanted us to go ahead and do this. So your tests don't always catch migration changes, so you can't necessarily rely on them in that regard. But you can see that testing helps you with a whole host of other things and helps you understand what's going on with your models, not only at sort of a field level, but also at a database querying level, which is very, very powerful.